Hey Frank, you might want to start that copy of that VM.
Hmm?
You might want to start the copy of the VM on that
Oh.
hard drive that I gave you up there.
Oh, this. Okay.
It's going to be TSD, whatever. Zip.
Is it already plugged into power?
Yep.
Okay. Okay, so we talked about triage. Well, we kind of sort of talked about triage. We're talking about triage in the sense of defense. We're talking from a how do I quickly determine that what I'm looking at is bad if we don't know yet, and B, what information do I need from this right away in terms of at least from the defense perspective. When we talk in terms of triage, the quicker that you can get that information, the better. If there's an active infection on your network, if you detected something based off of previous analysis, and your detection wasn't just something was attempted, but oh no, something is actually like beaconing out and is on our network. That is beaconing out and that is on your network. And if you're handed malware and somebody goes, figure out how we can successfully clean this off of the system rather than just block it. Or how do we get a handle on the entire infection, because we know that just because we got this one alert, that doesn't mean that that's all that's there. They want that information like yesterday. And how do you set yourself up so that you can do something like that quickly? That is part of your triage. Yeah.
For what it's worth, there was a good talk at the Shimon Khan about persistence techniques.
Mm-hmm.
And the presenter's kind of overall thing was give up, reformat, reinstall. Do not, particularly advanced adversaries will figure out obscure ways to persist that are very, very hard to defeat.
That presenter was completely misguided, and 6 out of the 8 techniques that they talked about and said were completely undetectable are detectable by auto-run study.
I have no doubt of that last part.
They didn't know what they were talking about. They quite frankly embarrassed themselves by saying like, oh, well, I had to come back for another engagement because they missed this the first time, where if the presenter had known about auto-runs and just used it, they would have found it.
Did you beat him at that first talk?
I did not. There were other people who emailed him. So.
Got it.
Yeah, I disagree with the premise on that one. It is a fight worth fighting. Don't just give up. But even so, having said that, even if we assume that the folks that you're supporting, when they find something that they do, their cleanup measures are just image it, that doesn't mean that that's what you do as soon as you detect something. Especially as your detection mechanisms start to jump across that or come across up to the line of no shit, something happened, versus this is kind of suspicious, we need to look into it. More and more what ends up happening is you create this is suspicious, we need to look into it, because that's how you detect new things and not just the things that everybody's already seen. And when you get this is suspicious, we need to look into it, then that's when you do your triage mechanism to, okay, let's try to quickly determine, is there actually something there? And that's when we get into these attributes of triage, that you want it to be scriptable, and like I was saying, consume minimal time and resources, especially analyst time and resources, and logged, or another way of saying that is searchable, those results you want to be able to leverage to say, okay, this wasn't something, still log that and have it searchable and mark that as, hey, this wasn't something, so that if you get something further down the line, you can go, oh, this looks exactly like, what happened before, and we determined that it wasn't anything. Or, and I have seen this happen, oh, hey, look, we got something, and it is something, and oh, it looks like something that we didn't think was anything before, and you look into that old thing and you go, oops, that was something.
What sort of database, in terms of logging, what's a good way to do this? Maybe have a wiki for each thing that the human looks at? Or
It depends on the size of your team, the resources, the technical capabilities. That is a lovely security engineering question there, where the devil is totally in the details. Having said that, Google appliance and throw it into that so that at least your notes are searchable. I mean, that's kind of like the bare bones approach. I mean, Google appliance, if you want to buy that, or the Lucene Solar stuff if you want to go the open source route. I mean, just so that you can at least search through your stuff. I mean, throw it on a file share, grab it. I mean, bare minimum there. Or anything up to, we have this fabulous system that we've been developing for years that helps us with correlation and such and such.
Basically, you're talking about any full text index searchable system that allows you to find things quickly in free form text.
Yeah, I mean, that I would say something that just does a free-form text index searchable would be your very basic. If you're working in a security operations center, you want that.
For what it's worth, Frank, I think this is an area more of solutions that you or other seasoned malware analysts can share that can apply to other minor sponsors. That would be really helpful because a lot of our sponsors have no idea where to start in this area. And in a lot of cases, they only have like a dude, doing malware analysis.
Right. Okay. So in terms of reverse engineering of malware or malware analysis in general, some of the common tasks for triage are going to be kind of your basic static stuff, file hashes, start getting into the fuzzy hashes with SSD. I didn't add it on there, but it's worth mentioning there was a paper a few years ago, author of a tool called SD hash. That is another fuzzy hashing tool. I haven't looked into it too much myself because we're doing okay with SSD, but the paper that the SD hash author released was specifically comparing SD hash with SSD, and for specific file types, your Microsoft Office file types, your pretty much documents, PDF documents, for those things, SD hash seemed to do a little bit better in terms of correlating things that were similar. Any question?
So when you generate hashes, MD5s and SHA-1s are pretty easy to index and search because they're static.
Mm-hmm.
SSD has its own comparator function that gives you a score, but it's hard to directly compare the values that come out of SSD to be able to generate take two random hash values and generate a score. You have to do that every time you search as opposed to being able to recalculate that. Do you find that to be a problem?
Well, that's kind of a how do you search question, and there's research and stuff into that is a solvable problem.
Okay.
Let me just put it that way. Yeah, that is a solvable problem. One of the things I'll say, just from let's talk bare bones again. fuzzy hashing. Why did we start using SSD? Because when one person pulls a PE file off of the carpet, off of a disk from a forensic image, one person pulls it out of packet capture using one method, another person pulls it out of packet capture using a different method. Maybe they missed some bytes at the end, maybe got a few extra zeros at the end, totally throws off your MD5 or SHA-1 hashes. SSD will say, oh, these are 98, 99%, 100% similar in the case where it's just some null bytes at the end. That was like kind of an immediate a duh moment for why we should start using SSD. There are different ways of getting the malware. I don't think that what you get there is only one way of getting that. Keep in mind that it can be coming from all these different sources, and just because the MD5s don't match doesn't mean it's not exactly the same way. File type identification is another part of the triage. Is this a PDF? Is this a Windows P file? Is it a Linux ELF file? PEID is good for detecting the compiler, and we'll actually be using PEID, as well as it has some detection of packers that it is aware of. Entropy analysis, which again we'll get into. Your very basic strings, what are the strings in this binary? And we saw that in the intro course. Just looking at the strings can sometimes help you figure out what you need to get it to run, or where malware is calling back to. Custom signature tools such as ClamAV and Yara, definitely suggest using those. You can create your own rules to say, hey, I've seen something like this before. If you come across malware that has a really unique function in it, or a really unique packer that the other tools don't detect. And then your kind of static header analysis, as well as dynamic analysis, the automation of that can help a lot as well with your triage.
The question about what Clam and Yara do. Does Yara do network and disk, or just one of them? And then same question for ClamAV.
What do you mean?
What does it scan?
You give it a blob of bytes, and it scans that.
Okay, for both of them?
For both of what?
For both ClamAV and Yara?
Yeah. So one of the things that you can get pretty complicated signatures with Yara, where you can actually say, in terms of the PE file, is this at the entry point? So it kind of knows something about the PE file format, but it doesn't assume that for the signatures.
Okay.
So you can write signatures that assume that, but you can also write signatures that just look for this string of bytes wherever in the blob of data that I'm giving.
So if you have a bunch of PCAP, it'll just literally look for that string of bytes in the PCAP. It won't say, oh, this looks like TCP, so I'm going to reconstruct it.
I don't believe, so I know Yara is aware of the PE file format. I don't believe it is PCAP file format aware. I'd have to double check the most recent documentation for it, but I don't believe that it is PCAP aware specifically. Having said that, MITRE open sourced a tool that you can use to process PCAP data with Yara. And you GitHub/MITRE CND, and it's off of there.